Great. So good afternoon and welcome to the 9th session of the Fall 2016 Sunoikisis Digital Classics module, which is the digital approaches to ancient history and archaeology part of the Sunoikisis program. This week's session 9 is going to be about data visualization, and we're very happy to be joined by Jonathan Blaney and Sarah Milligan from the Institute of Historical Research and Professor Jane Winters from the School of Advanced Study, who will be leading this session. And I believe Jane is going to start us off.
Great. Hello, everybody. We're just going to talk you through some of the theory around visualization and give you some examples of both good, well, what we think of as good and bad visualization, and get some conversation going around that. So visualization is talked about a lot in digital humanities now for the last 4 or 5 years. It's been really on the agenda, longer than that really, but it's far from being a new phenomenon. So I just wanted to start with a few historical examples to show you that ideas of visualization have been around for a very long time. This, for example, is a 13th century kinship diagram, which was used by the church to decide whether people were sufficiently distantly related to be allowed to marry. And it was a terribly complex system, and the only way that people could understand it was by visualizing it using these trees. Then here is that you'd probably be familiar with this, Brooks's slave ship, which is a late 18th century diagram, which really dramatically and viscerally got home to people the experience that people would have had on slave ships in a way that a description would never have managed to do. And it was repeated and used in evidence and so on. And it's a really dramatic example of a visualization being used to communicate something very important and lead eventually to changes in law and policy change. Graphical representation of statistics is quite often talked about as being developed by William Playfair, who was a Scottish engineer and political economist who was born in 1759. And he is the person responsible for, among other things, the pie chart, which is often viewed as not a very good way of representing statistical information, but also bar charts, line charts, and so on. And that's really when the kind of statistical representation that we recognize as visualization today began to gain ground. So why do we visualize data? The main reason is to make it easier to understand, and that's both for yourself, for your own research purposes, but also for other people. It's to reveal patterns that would not otherwise be discernible. Otherwise, in some ways, what's the point of visualizing something other than to tell you something that you couldn't find out another way? And that's particularly true when we're dealing with large-scale data that it's very difficult to comprehend in other ways. Data that's too big for you to read, so you need to find other ways of understanding it and finding out what kind of patterns are underlying it and whether that communicates anything meaningful for your research. It might also be used to tell a particular narrative. You'll see some examples later on of visualizations that can be used to present the same information in very different ways, depending what story it is you want to communicate to the people looking at it. Interactive visualization also allows people to explore data in a way that suits them. You might want to communicate one particular narrative, but they might be interested in something else. So increasingly, visualization offers those exploratory routes for your audience to work with data and try and understand it in a way that's meaningful for them. So visualization is both a means of communicating something or multiple things and a tool for research. And there's a lot of overlap between those two different functions. Thinking about what can be visualized, statistical information we've just seen, that's very often the case. In news media, visualization is particularly a concern with statistical information of all different kinds. Geographical information, so variations on all sorts of mapping, and there are lots of open source tools around to do that now. And a lot of digital humanities projects use geographical mapping to illustrate particular points or identify geographical clusters of information. Relationships and networks are very commonly visualized. Communication, information flow, knowledge exchange, a lot of early modern relationship networks particularly developed, and it can be a really instructive way of connecting people who you might not have realised were linked to each other. Images, increasingly, any element of an image, it could be architectural detail, it could be particular colour, it could be the pose of individuals in an image data set. Google Images is starting to do that sort of work as well. The occurrence of words or concepts in a corpus, computational linguistics is very interested in that area. Text and textual structure, punctuation even, buildings and open spaces, that spatial, 3D spatial representation is something that I think researchers are increasingly interested in, because it can tell you all sorts of exciting things about how people would have acted and lived within a particular space that would be very difficult to get from just looking at flat plans. So that's quite a long-winded way of saying really that you can visualize pretty much anything. It doesn't have to be structured. A messy text corpus can be visualized, but the more structured the data you have, the easier it will be to visualize, and the easier it will be for you to understand exactly what it is you want to get out of that visualization. So we're going to show you now some examples of visualization for critique and discussion as to what works, what doesn't, what might be a meaningful representation, what's not so useful. And I will pass over to my colleague Jonathan to start off.
So my first visualization that I've chosen for us to look at is the English Premier League, which is football or soccer. And these are the standings at the very top of the league as of about a week ago. I've really chosen this because it's pretty simple in terms of visualization. It doesn't have to be complicated. It's got two elements to it rather than one. The club badges, which are next to the names, that might seem like decoration, but if you're a football fan, you'll know that spotting your club badge is like seeing your child's face in a crowded playground. And on the right-hand side, I'm interested in this form guide that they have, which is the last 5 games that the club played, and green means a win, red means a loss, and the grey dot means a draw. So do you want to have any immediate critiques of this as a visualization?
Well, I have to say, when I looked at it, I didn't realise what the form bit was showing. When it was explained that that was what it was, I understood it, and it, you know, it makes sense, but I didn't instinctively realise what that was telling me.
I think because we're not quite as used, you and I perhaps, we're not football fans, are not quite as used to seeing this data, and so it doesn't immediately jump out to us to know what it is.
I also, I mean, I understand what those 5 lozenges at the right-hand side mean, but I always forget in which order they are. So did Man City lose their most recent game, or did they draw their most recent game? That's
Yeah.
something that I need to check every now and again if I care about that sort of thing.
Good point, Gabby. I think this is interesting for me because I follow it quite closely. It's really obvious which, you know, because I look at my own club's form, and that of course is written into my soul as either great joy or great misery. So it's the right-hand side lozenge is the most recent game. Yeah,
but that needs to be communicated somewhere, doesn't it? And
I think so.
If this is to be made clear because if you know your form that well, then you don't need the visualization of it.
That's good, but I guess you might look at the visualization of the club you're about to play next and find out how they're doing in terms of form. One thing that I noticed was that there's red and green used. So I sent this to my brother, who's a football fan and red-green colorblind, and he said he can't distinguish the different lozenges at all. He said, obviously, it's fine if you've got Man City who've got an up and a down, but when you have something like Chelsea, he couldn't immediately tell if that was a win or a loss. And although he knew from context they'd won 5 in a row because they're at the top of the league, he felt that was doing too much cognitive work just because he's red-green colorblind. So I think they made a bad choice of colors with this design. Should we move on to the next one? And this one I got from a really great site. I picked it almost at random. It's called Hand Drawn Maps. And it is exactly what you'd expect. It's hand-drawn maps of all kinds. This is how to get to Jen's house, which I think is in Brooklyn, from the airport in New York. And I've really picked it because I think drawing yourself or for other people is a really great way to visualize things, because you naturally simplify things in the way that you don't if you're creating things with a machine. So if you'd taken a map from Google Maps and annotated it, you'd have loads and loads of extraneous details for how to get to Jen's house. But when you draw it yourself, you really focus on what's important about communicating exactly the details you want. So it's very much visualization as, if you like, selling a message rather than exploring the data overall. Any comments on the map to Jen's house?
First thing that occurs to me is again the question of documentation. If presumably whoever drew this map, so Chad, who drew this map and gave it to whoever was trying to get to Jen's house, drew it in front of them and explained what they were doing as they were going. So the person the map was a useful reminder of what had already been explained. But otherwise, it's not clear to me, not having been there for that explanation, necessarily exactly what's going on.
When I looked at it closely, I thought I could probably get to the right metro station for Jen's house. And it may be that the original map had Jen's address on it, but obviously you wouldn't put that on the internet. So maybe they cleaned it up a bit, but I know what you mean.
Yeah.
But both of those examples say interesting things about context, don't they? That it's the first one, it's much easier to understand if you understand what's happening with soccer. The second one, it's easy to understand if you were there when it was being produced, but less so to somebody else. So that context and understanding, and in that case, involvement in the production of the visualization is important.
But I guess as well that the latter example does emphasize that visualization need not be a broadcast medium. It can just be from one person to another who knows the context, or even just for yourself. There's lots of sort of doodle things on the internet where people trying to explain a difficult concept will actually do it with little sketchbooks, very kind of stick man type drawings, as a way of understanding it themselves, but also communicating it. Can we move on?
Great, so right now I'm going to talk a little bit about, Bob Taylor wrote an article for Medium called Brexit, A Story of Maps. And he showed different ways of visualizing data so effectively that I thought I would just use that as a model and follow along what he went through in his article, because it's really effective, I think, for thinking about the decisions and the data that goes into a visualization. So he takes as his starting point the map that was circulated quite widely following Brexit in various versions. So there's examples here from Telegraph, BBC News, and a map that was held up in Parliament. The data that's being demonstrated here is whether a particular voting area voted yes or no. So what Taylor was interested in learning is what the actual mood and feeling of the country was like. And he thought it would be much less black and white or gold and blue or whatever color scheme it is that we want to look at. So Taylor decided to instead display a map, or display the data as a heat map, and gave each individual area a color based on how it voted. So a high leave percentage is colored dark blue, and a high remain percentage is shown in yellow or bright or green. This map visualization immediately tells a much more complex story than the previous ones. However, Taylor argues that this map is disproportionately representative if we want to really know how many people actually voted one way or another. So Scotland obviously stands out as being quite light green, whereas London is sort of a bit harder to pick out and doesn't quite seem as important. So Taylor next scaled the map to population. And while Scotland still stands out, London's influence immediately becomes much more apparent. So through each of these, he's adding more and more data to the map and trying to get a more accurate picture. But obviously the map or the visualization gets more and more complicated. So in showing all of these maps, or the maps so far, the data is only showing the people who actually voted. And Taylor now decides he wants to incorporate those who didn't vote to paint an even stronger picture of what is going on in the country. So for the next map that I'm going to show you, he's made the following changes. The voting turnout areas with a lower voter turnout are made more transparent and therefore de-emphasized. And he adjusts the color scale, which was 20 to 80% in the previous plots, now goes for the full range of 0 to 100%. So the map will have less contrast, but this way only the strongest results will be strongly colored. And then he's also added a background green color, which corresponds to a 50-50 result. Areas that are equally split will start to disappear into the background. Leave areas will be darker than the background and remain areas will be lighter. So this is what we get next. As you can see, that's a pretty big difference from the original maps that we started with. So I don't know if you want to comment on the transition between these.
I think as someone from the UK, it's slightly odd to see the country landmass deformed. And I'm not offended by it in any way, but I think it's slightly counterintuitive. It sort of, for me, steals my attention more than the colours on the map. I'm looking at the shapes and what's happened to Northern Ireland and so on.
I also think that the first one may not have been presenting really the correct picture, but it was presenting a picture that was easy to understand. Yeah. It was very stark, the vote yes, vote no, whereas this version, I would need to read all of the explanatory information that you've just given me in order to understand what's going on. So it may be more accurate, but for me, I think it's harder to interpret.
And I think that's part of Taylor's point, is that the more data that you add, the messier and more complicated visualizations become.
Yeah, I agree with Jane's comments on, especially with regard to the penultimate map you showed. There already, it's hard to see what's going on, because the scale from, what does mid green mean? Does that slightly darker green mean sort of 55%, or does it mean 45%? But on the last map in particular, something that is disappearing into the background, as you said, could be either because it was a 50-50 split, or because there was a low voter turnout, so it was being made transparent. Both of those would have the same effect of making it sort of fade into the background, and that then means that I no longer know whether there was a 50-50 split in this sort of mid-country block there, or whether it was massively pro-exit, but only 20% of the population voted. So it's added an axis, but that axis is ambiguous, I think.
Yeah, and I think that's exactly what the visualization is intended to do. It's intended to show that the stark contrast between leave and remain is not actually much of a contrast at all. So it doesn't make sense as a standalone visualization, but I think looking at the transition and thinking about the data that is being added shows that visualizations, or effective visualizations, simplify data, and that's the way that they work. But if we want to look at all the messiness of data, our visualization becomes much more complicated quite quickly.
That comes back to that sort of comparison between whether you're using it for research purposes or whether you're using it to try to communicate something that we started off with. Yeah. And that this is obviously, once you understand what's going on, much more helpful for research purposes, but you can see why nobody would have brandished that in Parliament to explain what had happened, whereas the much simpler and simplified message in the first one is something that people understood and shared with each other.
And maybe our instant understanding of the first map that Sarah showed actually shows our own misunderstanding of the situation, that it just is a lot more complex. And I've read many explanations of Brexit and they're all different. So maybe the simple visualization simply are us kidding ourselves. And this one actually represents the fog of reality.
Yeah, I think Taylor's point is that Brexit is actually much closer to, or just much more ambiguous and not a clear, not clear black and white, obviously. Yeah.
It's also another visualization that's very reliant on colour.
Yes, it is.
And if you're not very good at picking up contrast, particularly this last map, it would be very difficult to interpret, I think. And colour does seem to be something that it runs across the ones that I'm going to show in a minute as well. And I guess we should think a bit more carefully about using colour to communicate really important information. Okay, the examples that I'm going to show now, this stylometry and trying to get at an author's style of writing and using visualization to help do that. This is a blog by Adam Calhoun, and he has visualized texts in different ways and presented them there. And I'll run through the 3 different ways, and then we can perhaps think about what's most effective, you know, what's the immediate thing you take away from it. This first one is 3 different texts: Wizard of Oz, Absalom, Absalom, and A Farewell to Arms. And Adam actually admits that he says at the end, I'm just going to lay this out here without further comment, because I think really it's pretty. They do look different colours, but it's actually very difficult to interpret, I think, what's going on there. Commas and quotation marks are green, semicolons and colons are blue, and full stops and question marks are red. So, so the different tinge of the colours does tell you something. I'm just not entirely sure what that something is, but it'd be interesting to hear from other people. So a second, much simpler version is contrasting Cormac McCarthy's Blood Meridian on one side with William Faulkner's Absalom, Absalom. And this is exactly the same information, but it's represented as a bar chart. So I think you can get a much clearer sense of the actual data from this one than you can from the first one. You can see, for example, that Absalom, Absalom has a higher proportion of commas than anything else, Blood Meridian, full stops, and so on. But his final visualization of those 2 texts is actually rather beautiful in its own way, I think, and really gets to the heart of the style. You've got this very stark, lots of full stops over on the left-hand side from Cormac McCarthy, which gives that impression of lots of white space, and I think helps you understand a little bit about the type of prose that he uses. And on the right-hand side, it's just bursting with all this messiness with different punctuation and brackets and semicolons and all sorts of different. And so you get that sense of busyness and a much more kind of rich, dense way of writing. So, but that's my take on those 3 different ways of visualizing text. So I'd be interested to know what other people take away from those 3.
I haven't read Frank L. Baum, who wrote The Wizard of Oz. I don't think I get any sense of what his prose is like at all from looking at it visualized in that way. And I have read Faulkner and Hemingway, and I can kind of see once it's explained what's going on, but I knew that anyway. But it doesn't give me insight into something I haven't read, I don't think.
Well, all it tells you is that there's a certain amount of blue, so you must use a certain number of semicolons and colons, which maybe dates it, but which would be surprising for a children's book now, but maybe less so a time ago. But I don't know. Whereas Farewell to Arms is almost all red, right? And I mean, I can't see any green in either Wizard of Oz or Farewell to Arms, so that's those are both very low in commas. Whereas Absalom, I can see a little bit of green in there, but I'd kind of expect to see lots and lots more green, especially given some of the examples we've seen in the other visualizations. Mm. But yeah, I mean, this isn't terribly meaningful observation. It's just, it's trying desperately to understand something.
I found, so if I can just go back to those 3. So the only one of those 3 that I've read is A Farewell to Arms. And to me, that one immediately, it actually speaks quite strongly to Hemingway's style for me. Lots of short sentences. I mean, that is Hemingway. That's all you need to know about Hemingway. And knowing that one, I can then interpret the others much more clearly. Absalom obviously is an entirely different type of text from A Farewell to Arms. And even without having read it, I have a much stronger sense of what that's like.
I was just thinking that actually I'd rather be interested not in seeing different writers compared, but the same writer comparing different works. I was thinking you could even use it maybe for disputed works. So I'm thinking that the letters of St. Paul in the New Testament, half of them are thought to be not by St. Paul. So if you did some, I know there are complications with, Greek punctuation and so on, but something comparable there, that actually might be more interesting than comparing with a different author.
Yeah, punctuation would be a big problem with an ancient text because it's not there in the ancient text at all.
But you could use it with other.
But you could use other things like particles and other types of words. Yeah, I'd kind of like to see this at high resolution because I would like to see whether there are some sections of Farewell to Arms which you can identify because he suddenly starts using commas which he doesn't anywhere else. Things like that.
Okay, and the second of my visualizations is another one that uses lots of colour. This was an art installation at the Big Bang Data Exhibition here in London last year. And it's a representation of fatality statistics from the US Military Significant Actions database in Iraq. The data was released by WikiLeaks and cleaned up by The Guardian. The colours, even as described, are dark blue equals friendly troops, turquoise equals host nation troops, orange equals Iraqi civilians, and dark grey equals enemies. Those colours don't quite map onto what I see, and I'm not sure here which is dark grey and which is dark blue, actually. It's a little bit difficult to tell. But the key thing, I think, is that this is exactly the same data presented in a very different way. And for me, as a historian looking at this, the one on the left-hand side, the big pale section in the middle, is a really strong indication of the civilian casualties from this conflict. It really leaps out as that's the important piece of information that this visualization wants to communicate. Whereas on the other side, if you're much more interested in how the conflict played out over time, with concentrations of army casualties at the beginning and then getting into this civilian casualties later on, it has a very different purpose, and it tells you a different story from that data. And it also shows, I think, that even really horrible data like this can actually be used to produce something quite beautiful that you can display in an exhibition space. So thinking about visualization as objects which are actually beautiful to look at as well. But seeing them alongside each other said a lot about the choices that you make when you visualize something will affect very much what you communicate and what people will take away from it.
I think my immediate reaction is to think about how they collected the statistics on which this visualization is based, because I know there's lots and lots of dispute about civilian casualties in Iraq, and the figures quoted vary, I think, between about 200,000 and 1.5 million. So that makes me wonder, well, what was their criteria? And therefore, is this visualization even visualizing data that I might agree with if I knew the criteria?
I think this goes back to our point that visualization always simplifies. We have to make choices about what data we use. We can't visualize a range of potential casualties. We just have to pick a number and go with it. And the same for the descriptions of the groups being visualized: friendly troops, host nation troops, Iraqi civilians, and enemies. Those are obviously much more complex groups of people, but they are necessarily simplified for this visualization. Just a minor point that I appreciate with the visualization on the right, I think it's interesting that they did a sort of desert camo style to that visualization. It's immediately evocative of the war in Iraq.
My thought was that if for the visualization on the right to be meaningful, we'd have to have dates attached to it, or better than dates, because I'm not a historian. The dates wouldn't mean anything to me. Events. So where there's a sudden, quite near the bottom there, there's a sudden very dark area again, which might suggest troops were getting involved again in a way that they had been less so for the last several months or years. To be able to attach meaning to some of this would be useful.
Yeah.
Great. So now we've talked a bit about different types of visualization and what works and what doesn't. So the next thing that we want to do is start to think about how to actually create a visualization. So I'm going to talk about a bit of software called Tableau Public, which is free and can be downloaded. It is public, as the name suggests. That means that data that is created and shared on Tableau Public is available for anyone to look at. I think you can restrict, add some restrictions, but it is sort of out there. So it wouldn't be an appropriate place for private data, just as a slight disclaimer. So I'm going to just drag my Tableau window into here and just sort of walk you through what you can do with Tableau quite quickly. I'll keep this fairly simple, but hopefully just it'll just give you an idea of how easy it is to use, and it'll be a good starting point. So I'm in my Tableau Public book, and the first thing I'm going to do is get some data. So I'm interested in an Excel file, and I run a project called British History Online. So the data that I'm going to use is a list of our subscribing institutions by country. So I just have, you can see my data here from the Excel spreadsheet. I just have two columns, the name of the institution and the country. And already Tableau has recognized that I have a geographic role here in country, and it's figured that out. So I have my data. I can scroll down and check that it's all there and correct. The next thing that I'm going to do is go to a worksheet, which looks like this. So this is the starting point and where I can start to build my visualization. So you can see here that it's organized by dimensions, which has my country and username columns, and measures. So it's suggesting latitude and longitude, and number of records and measure values. So I'm going to drag my country into this field, into my sheet, I mean, and just see what I have. All right, so I have countries. It has obviously found the countries that are included in my Excel spreadsheet. That doesn't really tell me very much. I know that these countries are there already. So the next thing that I'm going to do is drag this number of records measure into my worksheet. So what's happened now is that it's created these different marks based on how many records there are per country. So I can see that most of our institutions that subscribe are, unsurprisingly, in the UK and the US, and there's a few others dotted around, but they're significant differences. So that's all good, but I feel like I can do more with this. So I'm going to drag my number of records again up into this colors section here. So what's happened now is that my colors are darker based on where the highest number of records are. And what I'm going to do is go into my colors and edit the colors. BHO's colors are teal, so this is sort of close, and I'll go with these colors. I'm finding now, though, that the small points are quite small, and I don't actually like that. So I'm going to go into size and change those sizes a bit. But then what happens is my institutions in Europe get all mixed up. So actually, maybe these marks are not the most useful. So I'm going to go up here and switch from the circles to a filled map, which gives me a much clearer visualization. Just to really stand these out, I'm going to add a little border just to emphasize my countries a little bit. So that's great. Now I have Again, a color-based visualization with it being obvious where the countries with lots of records are versus the countries that don't have very much. I'm going to go down here and name my sheet. So that will be BHO subs map. Oops. That's great, but we've already talked a bit about how color isn't always the most useful way of visualizing. So what's something else I can do? So I'm going to make a new sheet, and I'm going to do the same thing, drag my countries and my number of records, and it's made a map again. But I'm actually going to make a different type of visualization this time. So I've gone up into the show me, and I'm choosing bars instead. So this presents the same information in a different way, and obviously if makes it much clearer the distinctions between, say, UK and US, or Australia and Canada, which look quite similar on my map. For consistency's sake, I'm going to edit my colors. What am I missing here? Sorry, I can't quite remember what I'm supposed to do here to give my my range, but you can get the idea that at least my colors are consistent with the other part of my map. So I'll name this sheet as well. BHO subs are. Okay, so now I have two different visualizations of the same information. If I wanted to show this to someone, it might be useful to put these together and get, the same information all together. So what I'm going to do now is open a dashboard. And then you can see my sheets in the left-hand column here. And I'm going to drag those in. So now I have them side by side. I'm also going to change my size so that it fits a bit more. So now I have a dashboard that's showing my information. I'm going to, sorry about that. I can also look here, I can preview different devices, how this information would look on a tablet or on a phone, or the default is a desktop. Oh, no, sorry, that's a desktop. The default is just what is most useful for looking at it now. Great, so I have all this information here. I have a nice visualization. It just took me a few minutes to do. Obviously, I could spend a lot more time finessing this so that it's a bit neater, but that was just a few minutes to get that done. So what I can do now is save to Tableau Public. I'll give it a name, BHO subs. Save. And now, in just a moment, I have my visualization and I can share this. I can embed the code. I can share a link. I can send it to our stakeholders and give them an idea of who subscribes to British History Online. So I just wanted to sort of, I think it can be really intimidating to look at visualization software, and since Tableau is free and fairly easy to use, I wanted to demystify it a bit and give everyone an idea of where they can start. So now I will hand back to Jonathan.
So what I'd like to do now is to just show you 3 different open source free and cross-platform tools for modeling, mostly data, but also there's some other visualization possibilities here as well. So I'll start with Matplotlib, which is part of the Python library. And before I talk about that, I'm just going to recommend that if you want to learn Python or lots of other languages nowadays, you should look into the Jupyter Notebook, which used to be called the IPython Notebook. It boasts 40 language support these days. If I call it IPython Notebook by mistake in the next few minutes, that's because that's how I used to refer to it. But I'm not going to talk about R, which is a great language as far as I know for visualizing graphs and things like that, because I don't know anything about R. But I'm not saying there's anything wrong with it. So if you're interested in R, I think it's a great choice. So just to show you an IPython notebook, these run in the server, on a local server in your browser. And they're great for learning a language like Python, because the code is broken up into individual cells, which you can manipulate individually. And you can make small changes in the middle of a long script and see what happens. And this is actually from a bit of code that Sarah and I wrote about 18 months ago for a very complicated task we had. And what we've done is we filled it with sanity checks. So not only do we have lots of comments for our cells, which you can see, for example, at the top, telling us, reminding us what we're doing, but things like page nums and file numbers, which you can see in a couple of those cells on their own, are simply Jupyter Notebook's way of showing you what your variable is at that point in the code. And if we run this, if we run all the cells, it would look like that. Well, that's a snippet of it. And you can see that what we did here was we checked that the page numbers we'd got from somewhere else really look like page numbers. And I think you'd agree they do look like page numbers, and they're in order sequentially, and they look like the right kinds of numbers we'd expect. So that's all good. So bearing that in mind, I've written a very short and simple pie chart Matplotlib script here in Python in the notebook. And I thought Jane mentioned pie charts earlier, so I thought, well, can I possibly redeem the pie chart as a way of visualizing data? So I thought I will try to visualize the welfare budget in the UK, because that really is, in a sense, like a pie that gets divided up between different things. You can see it's a very simple script. I have to import Matplotlib because it's not part of the standard library. I've got 3 sets of variables there, which are just lists in Python, and then the bit at the bottom creates the chart and then shows it in a pop-up window, which looks like this when you run it. And surveys show that the public have absolutely no understanding of the way that the welfare budget breaks down. They tend to estimate about half of it goes on unemployment benefit, for example. And what you can see immediately here is that only 1% goes on unemployment. Most of it goes on pensions. But I'm not terribly happy with this visualization in well, a number of ways. Firstly, I think the 1.2 has kind of gone outside the bounds of that tiny little sliver of unemployment benefit. I think the shadow is unnecessary. I think the decimal point is also unnecessary. It seems kind of unnecessarily precise for this kind of chart. And the T of unemployment got missed off as well because of where it is. So if I just make some very small tweaks to the code, which I will just, what I've done in this 3rd cell down, this RC params, I've put the font size down to try and get it to fit. The next 3 cells exactly the same. I didn't touch those. I added an explode, which will explode out slightly the unemployment slice of the chart. And then I changed, if you look at the bottom cell, there's auto puct, which I think is auto %. I've taken that down to not showing any decimal places. I've moved with that PCT distance. I've moved the numbers on the wedges out a little bit, and I've exploded, and I've turned shadow to false. So if I run that now, this pops up in my browser, and I think it's a slightly improved chart, but now the labels are too small. So essentially my decision at the end of the day was that actually pie charts still are a bad idea, and that if people don't understand tables of figures, which you could present this as a table, then they're probably not going to understand the relative sizes of slices of a pie either. And what I want to do in each of these, I'll finish up on Matplotlib now, but with each one I want to show a good example of a visualization done by somebody else, not me, just to show what the capabilities are. So the next slide is a very pretty, but to me completely incomprehensible. It's a Fourier transform of something to do with quantum chemistry. I got that from the blog there. But it does show that something that all good plotting software should be able to do, which is to produce lots and lots of graphs next to each other, because visually we can pick out anomalies immediately. And I think you can see the very light blue one in the right-hand side. Somehow it's very different. So if you understood the chemistry, you would immediately go to that one. And you can do that with all kinds of data. And all three that I'm showing you today can do this kind of on block, lots of different graphs quickly. My next one is Ticks, which is, it's not just a plotting package. It's actually a much broader drawing package within LaTeX, which is a document preparation system. It's used a lot in the sciences and social sciences, and often science papers and things like that will have to be submitted in LaTeX. And I think this is, Ticks is worth learning if you're interested in learning LaTeX, and just in the same way that Matplotlib is worth learning if you're interested in learning Python. But for both of them, if you're not interested in that base knowledge, then it's probably not worth adding on the superstructure of this drawing program. Now, the next slide shows a complete document in LaTeX I've created. All I had to type in terms of actual variables are the green, the bits I've highlighted in green. And this is a bar chart of infant mortality. So if you look at how this would manifest immediately in a PDF, once I've run the command to create the PDF from the script, it's showing infant mortality. This is the highest Afghanistan, the lowest Monaco in the world as of 2015, and then a medium country, which is Sudan. And what I wanted to show here was the disparity between the very rich Monaco and Afghanistan. And the slightly surprising fact to me that Sudan, although it's we think of it as a very poor country, and I think it is a very poor country, its infant mortality is still half what Afghanistan has. But what's clearly wrong here is the scale, isn't it? Because its deaths per 1,000 is the measure of infant mortality, the bars could go up to 1,000, which would be everybody dying before the age of 5, which doesn't happen anywhere. So I thought, well, if I can make a quick change to the LaTeX script, I can maybe do a slightly better job. And all I have to change here to get this to be recalculated is the 115.8 I put in bold black there. That's the X max. So obviously it's the maximum of the X axis, which is the relative to Afghanistan. And I changed the title just to be clear, and that looks like this. And I think that's a bit better. I think, you do get a sense of the great disparity, but it's completely arbitrary to be using Afghanistan as the sort of ceiling measure. Why should that be? And so my conclusion again is that unless anyone else can suggest a good way of visualizing this with a bar chart, I don't really think it can be done. And so my next slide is how I would show this, which is simply putting like the figures in a table. I think that's very stark. So just to finish up, I've got two nice ticks, just showing what you can do with it. Here's some snowflakes generated from a mathematical formula that I found at that address there. And then the next one is a mind map, which is quite colorful and pretty. So I think ticks is quite hard to learn if you're not interested in LaTeX. But if you are, it makes sense quite well. So my last tool is the one I'm going to recommend for people, which is GNU Plot. And GNU Plot runs from the command line. So it looks like this. I hope that doesn't put anybody off because it's very powerful. And it's also, like anything with the command line, it's very quick. So I'm going to show you the data we're going to be working with GNU Plot. And this has been uploaded to the GitHub site, so you can download this data. This is a CSV of the catalogue for British History Online. So as was covered last week, it's comma separated values. This just represents 3 columns of a table separated by column. It's hard to see here rather than something like Excel, but it's much easier to deal with in text form than it would be in a binary format like Excel. And what we've got here are the titles of each book. Then the next number on the far right, or almost far right, is the date at which that book was originally published. And the last number is the date at which it was published on British History Online. And what I'm interested in visualizing here is the dates of publications originally, because we don't know what that data looks like. So I produced, from that, I munged that data into the next list, which is also on the wiki as I think it's called yearspub.dat, and this is a list of all the years represented in that list and the number of publications of that year. So there were 5 publications originally published in 1739. And that format there with the space after between the numbers instead of a comma is the default entry mode for GNU Plot. So GNU Plot understands that without any further work. So if we go back to the GNU Plot window, all I have to type to do an initial plot of that data is simply plot and then the name of the file in double quotes. And if you go to the next slide, we can see that I'm not going to show you everything in as a kind of screenshot of the window because it gets hard to read. So from now on, whatever I'm putting up there as courier is what you type directly into the GNU Plot window. So if we now run this, then up pops a window with this, which is a scatter graph, which is the default for GNU Plot of our publications on British History Online by original pub date. And I think immediately we can start to see something about the data, which is that there's a big cluster around about 1900 on either side of the turn of the century. There's also an outlier, I don't know if you can see it to the far right, around about 1760, where there are nearly 40 volumes published there. So that's quite interesting. It's also quite messy. So what I want to do is make a very small change and replot that. The first thing...
You also seem to have an outlier around 2040. Is that...
Sorry, Gabby?
You also seem to have an outlier around 2040. Is that an error?
That's slightly misleading because that's the key to the chart. It's saying that years pub is being plotted with the cross. Gotcha, and the reason for that is that you can plot multiple data sets onto the same plot. So if we had 3 or 4, it'd obviously be, we'd need to know which ones they were. Yeah. If there's only 1, it now looks like a dot, and I agree it's misleading.
Indeed, that should be flagged as the legend somehow. Yeah.
Yeah, and you can certainly turn that off if you want to. It's all within your control, but I won't show you how to do that. And Gabby mentioned 2040. Obviously, we have no books on British History Online originally published in 2040, despite how efficient Sarah and I are at publishing things. So, and we also know the data begins in 1633 because that's where our list began. So the first thing I want to do is to change the y-axis. So we just type that into the window. When you type anything with set into GNU Plot, it stays as the default until you change it or you close the session down. So everything I plot from now on, without adding this set range, will still be set to this y-axis of 1633 to 2015. So if we just plot that again, and remember that with the command line, you don't have to keep typing stuff. If you typed it before, the up arrow will always cycle through your previous commands. So you just have to do up arrow twice and hit return, and then you get the plot will be recalculated with the y-axis that we wanted. But it's still messy, so I want to make one more change, which is that I want to just add with lines on the end of my command to join up the lines. And if we run that plot, then we get something which I think is a bit more useful. We can see again that big spike down in 1760 or so, and then some quite messy, busy stuff going on around the turn of the 20th century. So what I want to do now is to actually reformat my data to make it less granular, because I think the problem here is that this is a year-by-year plotting, and actually I'd rather see it plotted by decade, which should smooth out some of the anomalies. So what I want to show you is how quickly and efficiently GNU Plot can recalculate your data. But to do it, I'm going to have to quite ponderously go through the way that it works. So it will kind of be in slow motion. I can't do it, I don't think, from the .dat file, the years pub dat I generated first. But if we go back to the CSV, what I can do is take out all of those years published again, and I can munge those figures into decades instead of having them year by year. So the next command will show you what you would type at the command line. This is the ordinary command line to do that. If you haven't used the command line much before, don't be intimidated by this. I promise you these commands, cut, sed, sort, and unique, are absolutely standard. So I'm not doing anything clever here at all, but I will talk through what they all do. So cut, the first one, is simply takes a column out of a columnar set of data like our CSV. We want the second column, if you remember, from our comma separated values. So that's F2. And then we want to tell it, because it's not the default, that the delimiter in comma separated values, as the name suggests, is a comma. So we have to say delimiter is a comma. And then we run that on catalog 3 cols CSV. And then that looks like, the output of that would look like this. That's all of our dates now in a list. And then what we want to do is then change them to decades. So here we'll use SED, which is a great tool for changing data files on the fly, and you can change multiple files and do all kinds of things with SED. We're just simply going to change every last digit in the years list to a 0 to flatten them out to decades. So the syntax for that is the S for substitute. And what I want to find goes in the first set of forward slashes. And I think last week you should have been doing a regular expression course. So you hopefully will recognize this. It's a very simple regex, which is saying find any number at the end of the line. So find the last number, because there's only one, and then swap it out for what's in the next set of forward slashes, a 0. And the G means do that for every line in the file. If you don't put the G on, only the first instance SED finds will get changed. And that gets piped through, and I should just say what pipes are. Pipes take the output of the previous command and send it to the next command. So it's like chaining them together. So our list that we got from cut will be sent to SED, and then SED will output this list, which is what we wanted. It's all decades now. And then we send that to the next command, which is sort numerically, and then make that a unique list, flatten it down to just each year, and then give me a count. That's what the C flag there after the unique means. It means give me a count of every one that you flatten down. That makes sense. And then what we get is this as our output. So that's now a list of every decade for every publication of British History Online, original publication date. And then all we need to do, although that's been a very long explanation, is we can simply stick that straight into the GNU plot command line, so it can take a command line argument of its own. So although it took me 5 minutes to explain that, it would only take me 10 seconds or so to type all this in and plot it, and I would actually be changing the data on the fly. And I could easily change it again to do by century or anything I wanted that I could think of how to do. And if we run that command, then we get this graph, which I think you'll agree gives us quite a different view of the data from the first graph. So first of all, that big spike around 1750 is now quite de-emphasized. Then what we see, starting in around 1850, is a big upward slope. And this corresponds very closely to what we know about Victorian history publishing. This is the date at which the Oxford English Dictionary was being written, at which the Oxford Dictionary of National Biography was being written for the first time. There are all these big publishing projects, including the ones that we have represented on BHO, going right up to the turn of the century. And then we get a sense of the kind of flagging of Victorian optimism, and it's going down. And then, of course, what you can see around the 1940s is a massive trough. And it's obviously the Second World War which is giving us that trough in publications. And a final thing I think we should be careful of is assuming that history publishing is somehow going down in the second half of the 20th century, because that tailing off at the top of the graph is actually because of copyright. We can only publish things on British History Online if they're out of copyright, everything that's effectively below about 1950, or we get permission from the owners, which doesn't very frequently happen. So I'm quite happy with that as a visualization now of the data. I think it's told me and Sarah things that we didn't really know before. And I think with a bit of cleaning up, which you can do with more messing around in GNU plot, we could even publish this on British History Online to show the spread of the data. So I'll just finish up with a couple of plots done by someone much more expert than me. So I mentioned before the way you can compare lots of different plots in one section. So that's a multi-plot there. And the last one is to do with building codes. And what I like here was the person who wrote this script created one PNG, and then GNU plot stretches the PNG or crushes it down to make it match what the bar chart should be showing. I think that's quite an effective way of visualizing that data. So to finish up, GNU plot would be my definite pick for the first thing you should learn, unless you have a particular reason you want to learn LaTeX or you want to learn Python or R. And I really did think this book was a great introduction to GNU plot. A lot of the online documentation is a bit hard to follow, but this is good. And there's now a third edition, which means that the second edition, which is what I've got, is available quite cheaply secondhand on Amazon and places like that. So that's the end of my little pitch for GNU plot, and I'll now hand over to Jane for the next section.
Right, I'm just going to finish up very quickly with some health warnings really about what you can draw from visualizations and about understanding your data, which builds on the point that Jonathan was just making. I imagine most of you will be familiar with an n-gram viewer for Google Books, for example, which visualizes the occurrences of particular words in a corpus of text. This is a very large, very messy corpus of text. It's the archive of the .uk web domain from 1996 to 2013. And it's a really messy data set, lots of duplication in there. And an n-gram viewer, I think, lulls you into a false sense of, this is lovely, smooth, I can understand, I can draw conclusions from this data, which is not necessarily there. This was a very early version of the n-gram viewer that we developed for this data set. And this is a representation of the occurrences of the words malaria, Ebola, and tuberculosis in the archive. And they look roughly similar in terms of their pattern, with a peak in 2007 and then another one in 2010. But we actually represented this in absolute numbers. So all that it's really showing you is the shape of the archive. Any word that you visualized would have exactly the same pattern, because collection reached a peak in 2007, and in 2009, for technological reasons, not as much data was collected. So you can visualize the shape of the archive there, but it's not telling you anything meaningful at all about those particular terms. And when this is adjusted to show the occurrence of those terms in relation to the archive as a whole, you get a completely different graph. And it shows you that malaria, as you might expect, is much higher throughout this period, and that there's an interesting peak in Ebola around about 2000, which wasn't visible on the other n-gram viewer visualization at all. So that comes back to scale, which Jonathan was mentioning with his Afghanistan example, and understanding the data and understanding your corpus, because you could have drawn conclusions from that first visualization, which would have been completely wrong. I think rather than working as research results in themselves, what this type of visualization is good for is illustrating trends, or just drawing attention to something that you might think you want to investigate a bit further. So I have a couple of examples here, particularly relevant in this context, just tracing the sort of fall out of favour of humanities computing as a term, and then the rise of digital humanities relatively recently. All you can really say about that is that one of them has become less frequent and one of them has become more frequent, but it's illustrative of a trend, and something that's worth looking at a bit more. I've done the same one twice, have I? What it is useful for is for the occurrence of new words, neologisms, and in this case, steampunk. And you can really see the birth of a word in the data set here. So 16 examples were found in 1996, and you're getting up to many, many more peaking in 2012. Incidentally, that drop on the end of all of these is again because the archiving only went halfway through 2013. So it's not indicative of a drop-off. If you know that the collection of the data stopped in April 2013, and that's what's going on there. So it can tell you something, but it shouldn't be taken as a firm research result. And I'll show you why a little bit later. Oh, here we are. This was an example of very early days of doing this kind of research. And this was somebody looking at expressions of courtesy and politeness in a textual corpus. And they produced this lovely n-gram viewer, which they interpreted as showing an increase in the occurrence of terms like politeness and courtesy around about 1800, which looks like a very interesting finding. But they hadn't really understood the data set that they were working with, and the fact that there was a typographical change around about 1800, moving away from S being printed as a character that's recognized by a computer as an F, and then the sort of S that we would recognize today. So we move from a long S to a modern S. And that is why that sudden uptick occurred at that particular point. So a bit of historical context on the data would have prevented that slight misinterpretation of what was going on. And even more significantly, they weren't able to reproduce their initial erroneous graph, because Google had helpfully corrected the algorithm so that it picked up that character correctly. So it's about reproduction of data there as well. So it's really important to document what you're doing, as they could do in this case, to explain why those mistakes had happened. So understanding your data is really important. Finally, I think I want to move on to the question of, should you visualize anything at all? This is a fantastic site called Hive Plot, and it has a whole series of these visualizations, which is described as yet another impenetrable but possibly beautiful network visualization. And they are rather lovely. The one on the bottom, for example, is the connections between artists on Last.fm in the linked open data cloud. It's lovely, but what exactly is it telling us? Is there any point in this kind of visualization? Thinking more carefully about what you do and avoiding that what's called the hairball effect. We had a researcher working with us here visualizing the terms used by women in parliamentary debate in historical Hansard. And this is his first visualization of the connection between the words that they use. And again, it's completely impenetrable. You have no idea what that's telling you. So he used word tuvek to produce that. But then using Gephi instead, so a different tool, same data, and you actually start to see something that looks like clusters of related terms, which is much more interesting than this big messy diagram on the left. And then when you drill down into that, you can start to see really interesting things. So this is the education cluster, and you can see the kinds of words that are being linked together when women are talking about education in parliamentary debate. So a huge range of things from apprenticeship to postgraduate education, but skills and vocational and science are in there quite a lot too. So think about the tools you're using, because that actually can affect what you want to communicate and the results you can get from it. It's not always just about the data, it can be about the text as well. So that's it from us. Thank you.
Great, thanks a lot, Jane and the others. I just wanted to end up by talking very briefly about the exercise that might come out of this, but I don't want to preempt any discussion that may come up or people may have. So I'll try to be very quick, because we've got about 10 minutes in which to do this. So as usual on the course outline page for session 9, there is at the bottom of the page there's a practical exercise. And what we wanted to suggest you did as the practical exercise for this was to, using Tableau Public, the tool that Sarah showed you, unless you're feeling very, very ambitious and you want to learn GNU plot in the next 4 days, which Jonathan insists is easy, but I think it might not be that easy. For a longer term project, GNU plot would probably be very useful, but for this exercise for this week, we might stick to Tableau Public. And simply to experiment with the different kinds of visualizations that Sarah showed, and the other kinds of visualizations that are available in Tableau, to try loading in various data sets that you have. Jonathan's made 2 sample data sets available, as he showed you, which are linked at the bottom of this page. You should have various other data sets left over from earlier in the term. That you'll have been playing with in some of the other classes. If you don't have any of those to hand, or you don't want to use those, you can very quickly generate a new data set from the Numisma triple store that we were looking at last week. One of the outputs from the Sparkle test interface you have there allows you to download your results as CSV, and so you can get a whole bunch of data there immediately, which you can immediately start visualizing. You can also download as CSV from Recogito, if you remember, from a few weeks ago. And although that actually is semicolon delimited values, and you have to then go through a slight chain of activities to turn that into comma separated values, we know how to do that. And so there's various ways you can come up with these data sets. And what you should try to do is find at least 2 data sets, 2 different data sets, preferably different kinds of data sets, but if they're two different data sets from the same source, that doesn't matter, so long as they're slightly different themselves. And try to create some visualizations that where the 2 data sets overlap. in some way. So both data sets have geographical information, or both data sets have date information, or some other piece of information is available in both of those, and see if you can visualize them together. Try at least 2 or 3 different visualizations with each with your set of data, and think about ways in which they could be improved. You may need to match some fields, you may need to modify data types, but end up with 2 different visualizations that do very different things with your data, visualize them in different ways, and be prepared to bring those along. Those of you who are in my class, bring them to my class next week. Elsewhere, you take them to your groups, your instructors, and be prepared to show your 2 visualizations and describe to the class how you came up with them and what you might do differently if the software let you, or if you learn to use the software better, and those will be discussed then. So that's basically the exercise. Does anyone have any suggestions they wanted to add to my explanation there?
I just wanted to say that Tableau has a lot of really useful videos, and you can learn how to use all the different aspects of it. And they're broken down, so they're not like a single long video. You can focus on what you're really interested in. So that is definitely worth checking out.
Great, thank you. Yes. Does anyone else have any questions or comments about this week's session? Anyone else? Simona or Sarah? The only other 2 people on the Hangout.
Nope, not questions really, but thanks. It was really cool and fun to have a look and discuss things on the go rather than that's a slideshow. Look at it after we're done talking. So I thought that was great. Thanks.
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 Cool. Thank you. Great. Anise also said she very much enjoyed the session. She had to leave early, but she did say thanks. And Sarah is also saying thanks in the chat window there. The only thing I wanted to add in that case, if we're done for this week, is that next week's session, which is on network analysis, in which you'll see some more of those exploding hairball type graphs, also known as spaghetti monsters, will take place 1 hour earlier than usual. So it'll be at 3 p.m. UK time, whatever time that is in your time zone. So just to be aware of that slight difference. Apologize if you can't make that session, but it'll be on YouTube afterwards as usual. Okay, great. So thank you very much again, Jane and Sarah and Jonathan, and speak to you all soon.
Thanks everyone for listening.
Thank you.
Thanks, Gabby.
Cheers.